Thank you for joining us this afternoon. We have a great talk by our very own friends at Docker, leveraging Kubernetes and Docker Enterprise Edition to power infrastructure at Docker. So it's literally Docker, probably on Docker. Let me invite to the stage Manish Tomar, Senior Software Engineer at Docker. Also, extraordinaire parasailer at Tahoe, where there are no whales. And Brett Inman, Senior Infrastructure Engineer, also at Docker. Thanks, guys.
Thanks, Tim.
Thank you.
Cool. So basically, the whole point of this talk is talking about how we use Docker Enterprise Edition at Docker to run all of our infrastructure. Why is that actually interesting or important? So the first thing is we are the first customer that uses this product, right? So we run all of our SaaS and internal workloads on this. We get the bits before everyone else. We actually have to run it before we can push it out to customers. And so we hope that we are able to share all the things that we've learned during that, best practices, tips, how we went through this process. And also, we just really want to talk about how we're actually dog fooding this product. So if you've heard the phrase, eat your own dog food, basically, we need to make sure that the product lives up to our expectations before we ship it. So quick agenda, we'll talk a little bit about the background of how we do infrastructure and services at Docker. We'll talk about what our planning process looked like for moving to Enterprise Edition 2.0. How we prepared our infrastructure, how we actually went about moving applications from Swarm to Kube, and then some of the features that we're leveraging in EE and Kubernetes now that we have that available to us. So for people who aren't familiar, Docker Enterprise Edition is the suite of products available commercially for Docker. Composes a few different things, including UCP, which is Universal Control Plane, which sits on top of Swarm and Kube. DTR, Docker Trusted Registry, that's the trusted registry, security scanning, all that kind of stuff. When I say SaaS, I'm usually referring to things like Docker Hub, Store, Cloud, that we run on our infrastructure, and it's actually Manish's team that runs those services. And a quick disclaimer, I'm going to mention a few different products, service providers, things like that. It doesn't mean that we think they're the best, that we necessarily endorse them. It's what works for our infrastructure and our needs. Cool. So some background on us actually running Enterprise Edition. We have about 200 hosts in production, comprising about 100 microservices. It powers Hub, Store, and Cloud. I'm sure you're familiar with all of those. Like Steve said yesterday, we do about 1 billion polls every 2 weeks, so it's quite large scale. And then we also now run our web properties on there, as well as our build and CI systems are in the process of moving right now. So what is actually infrastructure at Docker? So the goal of our team is to provide this self-service platform that our developers can build on top of. So basically, we're this middle slice here. We've got our cloud provider on the bottom, infrastructure. We're responsible for actually building up all those resources, installing UCP, DTR, all that kind of stuff, databases, and basically providing a layer that our developers can build on top of. So basically, what are the interfaces that we give to our developers? So the first one is obviously Docker Enterprise Edition. So they have access to that for using Swarm and Kube. We provide logging services as well as metrics and monitoring. So that's pretty much everything that we hand off to our developers, and they get to build the application up from there. And then obviously the role of development is to actually take all those resources and use them in a way that we can provide services to our customers. So a little bit of background on the dog fooding project at Docker. Obviously the goal for us is that we can provide feedback on the product, make sure it does what it's supposed to do, make sure it does what we want it to do before we actually hand it off to customers. And this is cross-functional. It's not just our team and Manish's team, but it's also, we have the product teams involved in this. So we would get everyone in a room, talk about it, make sure it does what we want it to do. We started this about 2 years ago. We spent about the first year and a half moving everything over to Swarm. And then now that we announced Kubernetes back in October at the Copenhagen DockerCon, we spent the time since then moving everything over to Kube as well. So I'll hand it over to Manish to talk about our planning process for this.
Thanks, Brett. So with respect to planning, we started planning with an explicit goal of migrating our existing cluster from EE1 to EE2. With that in mind, we set out a bunch of milestones. We assigned owners to them, and we assigned dates to them. The owners, depending on the milestones, were either EE team, infrastructure team, or application team. I'll talk about the milestones in the next slide. Once the dogfooding process started, we started having weekly syncs. That was primarily between infrastructure team and application team, where we communicated, technical aspects, any blockers, and basically keeping track of the milestones. And apart from that, we had a common Slack channel, Bound Dogfooding, where we invited basically everybody, all the stakeholders who's part of this whole effort to join the channel. So that included same infrastructure team, application team, engineering team, product team, senior management team. And it was a really good collaborative tool where every time during the whole process, if we had any issues, we were able to quickly resolve it on Slack. Finally, we made this whole process a release blocker. That meant that until we, that is infrastructure and application team, was comfortable running all of our SaaS services on EE2 for at least a week, our production services on EE2, we would not release it to the public. This is exactly how our planning process looked like. It primarily involved basically creating a separate test cluster, which is an exact replica of our staging and production cluster. It started with creating the test cluster, then deploying EE builds on that, then deploying Swarm and Kubernetes workloads on that. And in that whole process, if we find any issues, we'll file those issues back to the EE team. They'll get prioritized. That feature that included bug fixes. We filed bugs as well as feature requests as when we were using the product, and the cycle continued until we were until the EE builds were stable. And once the builds were stable, we upgraded our staging cluster from EE1 to EE2, and then we did the same thing. We deployed Swarm workloads. We made sure that the existing Swarm workloads on the staging cluster were not affected. We deployed Kubernetes workloads on those. We tested those. And finally, before releasing GA, we upgraded our production cluster from EE1 to EE2 without any downtime while serving traffic. We let that run for a week or so to make sure that it's running real-world tests. It's able to take production workload. And finally, we released it to the public. Now I'll hand it back to Brett to talk about all the infrastructure preparations he had to do.
Cool. So we went through our planning process and figured out a plan for this. The first thing we did was we built a test cluster. So all of our infrastructure is defined as code. So this was actually relatively easy. We basically branched it, started making changes to it. And we knew that once we got it working in the test cluster, we could just take those changes, PR them back into stage and prod, and in theory, everything should work fine. It did, but we'll talk about that later. A few things to watch out for when you're doing this. Sizing is going to be important, especially if you've been running EE1 and you're upgrading to EE 2.0. Just be aware that now that Kubernetes is built into this, there's a lot more containers running on the managers. We recommend a minimum of 8 gigs RAM. For production, I would run 16 or 32. So you'll want to keep an eye on that. The other thing to watch out for is we do now support both orchestrators running in one cluster. But we do not recommend running them on the same nodes. So if you have one set of nodes already for Swarm, you'll want to spin up a new set of nodes, join them to the or to ECP as separate worker nodes for Kubernetes in this case. And so we manage that using actually UCP collections. So for Hub, for instance, we have one collection in Swarm and one collection in Kubernetes. And as we've moved workloads between those. Another thing that we had to take into account is networking. So networking Kubernetes is a little different than Swarm. Obviously, there's a lot of different plugins available. The one used in Enterprise Edition is Calico. Not going to get into the details too much, but basically it's based on BGP. And so we have this new routing mechanism we have to deal with, and we're trying to figure out how exactly we want to do load balancing, service discovery, all that kind of stuff. And so we started looking at what's available, and obviously one of the biggest things in Kube right now is ingress controllers. But we kind of looked around at those, and we found that they were, a lot of them are pretty early. They don't support all the features that we were using in our existing routing setup. So we were kind of debating, do we write a new one ourselves? Do we modify one of the existing ones? So we decided to step back a little bit instead. We went and said, well, what are the simpler mechanisms we can use? So Kubernetes has this concept of node port services. And this lets you specify a node on every port in the cluster that will be linked into a service behind it. So we decided to build on top of that. We come up with is this. It looks complicated, but I promise it's not that hard. So basically, we come into our infrastructure via an ELB. From there, we have an HA proxy layer. That's already existed. We were using that to route with Swarm. And what we've done with Kubernetes here is that we've exposed node port services on part of our Kubernetes cluster that we have set aside just for what we call routing. So these are Kubernetes workers inside of UCP, but we don't have them doing anything. They're not running workloads. All they're doing is exposing those node port services. And so we're having HA proxy talk to those on the certain port. So HA proxy gets a request for hub. It knows that it needs to go to one of those routing nodes on port, whatever we assign for hub. So in this case, 32775. And from there, the routing nodes take over and the Calico network comes into play and it's routed to the correct pods over Calico. So we have a routing solution. It works pretty well. And the cool thing about this is because we kept our existing HA proxy layer, which we were using for Swarm, we can actually route to both Swarm and Kube at the same time. So this gave us the ability to move back and forth as we were comfortable. So we figured out routing, then we started looking at metrics. We use Prometheus. All of our SaaS applications that we build in-house have a Prometheus metrics endpoint built into them. It's a really good way to do metrics if you haven't looked at it. And for stuff that we don't have internally, that we use third-party applications, like say Logstash or something, we've built our own exporters for those. So we do have a Prometheus-style metrics endpoint that we can scrape. So back when we were in Swarm, for service discovery, we used Consul. So Prometheus supports Consul. And obviously, Consul doesn't play well with Kubernetes because of the way that they've changed the networking with Calico. So instead, Prometheus supports the Kube API directly. So it just talks to the Kube API and asks, where are these pods, and it gets an answer. So it's actually pretty easy. This is our Prometheus configuration specifically for the Kubernetes stuff. You see just in red, we're using the built-in Kubernetes SD configs. And then we just tell it where the API server is, and we give it a service token. And it's set. It just talks to the Kube API, says, where's the stuff? Kube tells it where it is. Easy. And the one thing that was actually way easier for us is logging. So the cool thing about supporting both Swarm and Kube is really their orchestration layer. They don't do anything on the engine and container level. So if you have logging set up already for your containers in Swarm or anywhere else, nothing changes here. This is an example of our logging pipeline. Details aren't important. All that matters is that we didn't have to make any changes to this. And then we started thinking about how we're actually going to do the upgrade on the cluster. And this was actually the really easy part. So we ran one command, and we went from EE1 something to EE2.0. It's really this one UCP command, and all you tell it is upgrade interactive with the version. And suddenly we went from a UCP cluster that supported Swarm to a UCP cluster that had Swarm and Kube. So I didn't install etcd, I didn't set it up, I didn't run through that Kubernetes the hard way document, like that was it. If you're a new customer, you haven't used UCP before, you can just swap upgrade for install. It's the same command, one line. So that was fun. A few things to watch out for, though, that we kind of hit in the process, so it wasn't quite that easy. You have to make sure that UCP images are accessible to every node in the cluster. So UCP images on hub are public, but if you're running on a private infrastructure or you're using pre-release bits that are private like us, you'll need to make sure that all of your nodes have the images pulled before you run the UCP upgrade, or it's going to roll back, and you're going to have to be in a weird state for a little bit. Same thing applies with down nodes. So if you've lost nodes, especially if you're in an environment like AWS where you have nodes come and go a lot, if any nodes are still marked as down in the cluster, even if they don't exist anymore, your UCP installation will fail and it will roll back. A note for those of you still running Ubuntu 14.04, there's some issues with shared mounts. Make sure you just read the release notes for this. It's a few command lines and you'll be fine. Load balancing, a thing to keep out for, to look out for there is we had exposed the Docker API on port 443. Now that we support Kube as well, you'll find that on port 6443 on the manager nodes. And keep an eye out for Kube DNS. It doesn't work quite the same way as normal engine DNS does, especially if you use localhost resolvers. So you may need to actually add a Kube DNS config when you deploy your applications there. And I'll hand over to Manish to talk about actually moving the applications.
Thank you, Brett. So as Brett mentioned earlier, we run roughly around 100 applications approximately on microservices in our cluster. And before we decided to move few applications to them, we decided to split up into these categories. So it's primarily non-critical and critical categories. And within each one of them, we had like low traffic, non-critical, high traffic, non-critical, low traffic, critical, and high traffic, critical. And then we decided to basically port the non-critical traffic, non-critical applications first. So within low traffic, non-critical category, we have a microservice called notifications. It's a very simple RESTful service which basically other services call to send out email out to users. It's low traffic in the sense we don't bombard our users with a lot of emails. It's roughly around 6 to 10 requests per minute. So it's a pretty low traffic site. It's non-critical in the sense that if the service goes down, there's only a percentage of users will get affected for that point of time. The rest of the website, other services will remain fine. The other application that we chose to port to Kubernetes was, which fits under the high traffic non-critical, is registry to SNS. Registry to SNS is basically a very simple HTTP server that receives webhook notifications from Hub registry, converts them into an SNS message, AWS SNS message, and puts them in an SNS topic. This is extremely high traffic because our Docker Hub registry is an extremely high traffic site. We get roughly around 1,500 to 2,000 pulls per second, and each of those pulls transports to roughly a single HTTP request. So this service is effectively processing 1,500 to 2,000 HTTP requests per second. So the nice part of migrating to Kubernetes was the things we didn't have to change, and these are the things we didn't have to change at all. You can see that we had there was no source code changes, there was no Docker file changes, which means the way the image was built was exactly the same. That means the CI part of building the image didn't change at all, and there were no environment changes. That means our containers expected certain environment basically to be run with the certain environment, and as long as they got that environment, whether it was Swarm or Kubernetes, they were happy with that. So what did change was, obviously, we had to add Kubernetes YAML file. So as part of the YAML file, we added the deployment object and a service object. I'll explain that in the next slide. We used something called registry secret. Kubernetes has a concept of secrets, which you can use in pods. One of the special type of secrets it has is a registry secret, which is basically credentials used to authenticate to a private registry. So all our images are stored in a private registry, and we store the credential to access the private registry in a registry secret. That will be shown in the deployment object. I'll show that in the next slide. And another nice thing was all of this is on the source control, which means we followed the regular development cycle. Each PR to add the YAML file was reviewed through, it went through the regular code review. Rest of the team members were aware of it, and there was one common source of truth. This is an example of the deployment object of registry to SNS, which I was talking about. So a deployment object, a Kubernetes deployment object basically describes the pods which are to be run. And the description of the pods contains two things primarily. One is the metadata, and another is the pod description. And the pod description is basically the container description. That is what images to run, from what image to pull, what environment variables, what port is exposed. The interesting bit here is in the metadata, you're basically labeling each pod with a particular value. So in this case, we are labeling app is equal to registry to we are labeling each pod with this app is equal to registry to SNS. I'll explain why that is important a little just in the next slide. Another interesting bit you can see is the image pull secrets. This basically tells Kubernetes to pull the image, in this case Docker/registry to SNS, from a private registry, and basically tells that use the credentials stored in this secret to authenticate to that registry. So this is the service object. Now, before I talk about the service object, you need to realize that our current cluster is effectively a large swarm cluster, and Kubernetes is a mini cluster running on that. And so Kubernetes network model is basically each pod gets its own separate IP, which is on a different subnet than the swarm containers. The swarm containers are basically running on host mode publishing, which means they are effectively on the host network. So for those pods to talk to, or especially for others, for the swarm containers to talk to this Kubernetes pods, it had to be exposed outside the Kubernetes cluster. And the Kubernetes way of doing that is by creating a service object. And so the type of service object which Brett mentioned here we are creating is a node port type service object. And the interesting bit of the service object is the node port config. You can see it's 32769. So using that, you're basically telling Kubernetes, or rather what Kubernetes does is, On every worker node, it opens this port, and any requests coming to this particular port on any of the worker nodes basically get transported to the pods, which are described using the selector field. And selector, if you can see, is registry to SNS, which is effectively the same, which is the label for the pods, which is described in the deployment object. So any request basically sent to any of the Kubernetes worker nodes on this port will automatically get routed to the pods which have that particular label, which in our case is the service which is servicing that. So this was basically the setup, and I'm just going to talk about how we did the migration. The migration was actually relatively simple. It involved ensuring that the pods were functioning correctly, and then so I'll talk about how did I ensure the pods were functioning correctly. So it started off by I would create a deployment object using kubectl command. I'll make sure that the pods were running, they were scheduled at the correct nodes. And once they were running, I would check the logs. As Brett mentioned, we have a pretty nice logging setup where each container's logs are ingested in Elasticsearch. So I'd make sure the logs are fine, the container is behaving fine. Once I was comfortable the container is behaving fine, I would create the service object to expose that the container's functionality to the outside world, which in our case is Swarm. And then I would send a request to this particular port, 32769, I showed in the previous slide. I would send a HTTP request on that port, which will basically redirect it to the pod. And that way I would make sure if I got a response back, that means the service was behaving fine. That means the pod was behaving fine. So this way I ensured that the pod is functioning. The best part of our infrastructure, or rather our cluster, is the fact that each service can be backed by a Swarm container or a Kubernetes pod. And this was really, really useful for me to migrate from Swarm to Kubernetes in production. So the way I did that is basically when we upgraded to EE2, I would start off with creating one pod. And the moment I would create a pod, it would start serving traffic. Harproxy would start serving traffic to that. I'll monitor the pod. I'll monitor. We have a lot of dashboards from Grafana. From Prometheus and Grafana. So I'll monitor the service. I will see if the service is behaving fine. If the service is fine, I'll slowly start adding more pods. And as and when each pod was added, it'll start getting traffic. And once I was comfortable after a while that the service was serving properly from the pods, I would basically remove the Swarm containers. So the service was completely backed by pods. And after that, once I was comfortable running it in production, I made a small change in our deploy tooling. We have an internal deploy tool which understands our directory structure. It knows where the configuration files are, where the compose files are, where the Kubernetes YAML files are. So I made a change in that where if you deploy registry to SNS, it'll automatically get deployed to, it'll know where the configuration file is, and it basically deploy to Swarm and Kubernetes both. Yeah, thanks. I'll give it back to Brett where he'll talk about all the new features of EE and Kubernetes that was used.
Cool. Yeah, so we set up a new cluster, we got everything running, we upgraded, we put some applications on it. What does that actually gain for us, right? So what are we getting out of this migration besides obviously testing this? So we used to have just the Docker API and UCP, right? So you can do Docker CLI commands, you can do Swarm, and of course UCP layers role-based access control on top of all those commands. So now with EE 2.0, we've extended that into Kube as well. So now there's a Kube API server. You can run kubectl against it. And again, we've layered UCP's role-based access controls on top of those commands. And of course, as usual, UCP gives us a standard web interface, so we can see everything pretty easily from there. So you have both choices. You can use either of the APIs through the command line or any other tools, or use the web UI. And a big feature for us that we use really extensively in UCP is resource sets. If you've used UCP in Swarm before, you may be familiar with collections. So collections have now been extended with Kubernetes as well to Kubernetes namespaces. So like I said earlier, we run separate collections for Swarm and for Kube. So for example, we run a collection within UCP for Swarm Hub and then a collection for Kubernetes Hub. And then there's also a lot of work that we do on the host layer for this too. So we run in AWS. If you're familiar with that, you assign IAM permissions at the host level. So we can't just have one big cluster with everyone running everywhere, because then you have permissions to everything, and that's really not a good idea. So what we do is we separate out by team. So each team has their own autoscaling or several autoscaling groups which map to a collection within UCP, and they only have access to deploy those applications onto those collections. So we're using role-based access control along with resource sets to make sure that people only deploy applications where they need with the permissions that they need. It helps us keep things clean and keep people from stepping on each other's toes too much. And actually, the cool thing about this too is I mentioned that we have access to the Kube API as well as UCP's API, and so we've extended this resource set idea with something that we call AirBoss. So it's a piece of software that we wrote that actually does a lot of the automation aspect. So a big thing for us is HA and being able to replace nodes automatically. And so normally with a UCP installation, when you join a node to it, it joins as either Swarm or Kube, and you can configure that default. But because we're running both Swarm and Kube at the same time, we need to be able to say, this one specifically should be a Swarm node, this one should be a Kube node. So we actually have integrated with the UCP API, where when a node joins, we'll actually go ahead and see that it joined and go and set the correct collection, set the correct orchestrator, as well as do a bunch of labeling stuff that makes it easier for us to just replace that node. So we're hoping that this kind of feature, either we open source this or it'll hopefully be integrated directly into UCP in some way. But it's just an example of what you can do to extend on top of this using the APIs available to you. And then a cool new feature for us in Kube that wasn't available in Swarm, pods. If you're not familiar with pods, basically it lets you deploy several containers together on the same host, so they're always, they go to the same place. So this is kind of useful for a few things. I mean, first of all, it really is helpful for breaking up monoliths. So if you have monolithic applications, you want to pull apart pieces of the code. Localhost still works within pods. So if you've always assumed that a database would be on the same server as the front end, this will still work within the pod. And the same thing for shared volumes. So you can mount a volume into all the containers in the pod and they can share a file system if necessary. For us, it's been really useful even with microservices because we can do metric exporters in pods. So every time we deploy a Logstash container, which doesn't support Prometheus metrics out of the box, we can deploy a exporter along with it. So we always know that every Logstash container has its own exporter, which has been really helpful. Cron jobs is a cool one for me personally. So obviously you're familiar with cron on the system. This extends cron into the container space. So Kube, you can define a cron job and it will run a container with whatever you specify on whatever schedule you want. So we've moved a lot of our system services like Docker prune, pruning images and stuff. We've actually moved those from the host level up to the container level by using this. And basically, what do we want you to take away from this talk? So the first easy thing is dogfooding. So we've gone through all this process, and it's at times been painful, and we hope that we've made the product better. And a small way we can measure that is just during the last few months, before we released EE 2.0, this effort uncovered 10 P0 and P1 bugs that got fixed before release. So we're pretty happy about that. And then over the course of the entire 2 years, we filed over 162 bugs and feature requests through this program. So hopefully it's better. And then what we really want you to take away from this talk is how you actually go about this process, right? So the big thing for us is planning. Setting up those milestones and those avenues of communication is really what made this work for us. So we got everyone in a room, we committed to it, and we said everyone's going to be fully aware, fully involved all the time. And then as far as running the infrastructure, we talked about a few things: sizing, resource sets. Make sure you have a good routing setup and you know how you are going to do that with Kube. And ideally, if you have a setup that can let you do Swarm and Kube at the same time, it'll make your life so much easier. Make sure you have metrics and monitoring that works for you, as well as we talked about some gotchas and notes, and you can refer back to that slide. And then also have a plan in place for your migration. So like Manish talked about, define which applications you're going to move, why you're going to move them, and maybe have a good reason to do those in some order that doesn't bring everything down. It's important if you're running a production service. And then also we encourage you to check out the new features in Enterprise Edition and Kube. So I mentioned a few of those. There's a lot more that we don't have time to cover, but please go try it out. If you have your own infrastructure, you can go to store.docker.com and get a trial license. If you just want to try this on the cloud, we have trial.docker.com, and you can go check it out. It'll spin up instances for you, and you can just play around with UCP, see how it works. And that's what we got. Thank you.
Thanks, Brett and Manish. That's awesome. The fact that you guys use Prometheus makes me happy inside. We do have time for questions. We've got about 11 minutes, so if there's some questions for these guys, feel free to step up to the mic over here and give them a hard time. Well, I know we do.
So you touched on it a little bit, but what were the benefits? Like, were there specific application use cases for running certain containers on Swarm versus Kubernetes? Did you find for the application side of things or from the infrastructure side of things, there were benefits of running them side by side?
So to be honest, I think the benefits of Kubernetes comes from the extra things which are there apart from Swarm. Those are basically service objects, and the cron jobs, for example, was really useful, as Brett mentioned. But from the application side, it was just basically porting the application. We wanted to make sure that we dog food Kubernetes. We want to make sure it works fine. So that was part of the reason why we migrated the applications. The applications are happy with Swarm too. But then the main part, like for example, service discovery and some kind of routing and all of that, that is already very nicely set up with Proxy, so we didn't have to do any of those things.
Yeah, there wasn't a big, I mean, as it stands, most of our stuff is still on Swarm, and we don't really have any plan to move it.
There's no reason to do that, yeah.
Everything works fine, so
yeah.
We're happy.
Can you talk about the cron jobs and how you use those to do the services, kind of like run services basically, but like set up? Because it's something that we're kind of struggling with now. We like using Kubernetes, especially the cron jobs for a lot of that sort of stuff, but we run into issues with some of the shared volumes or some of the secret sharing and that sort of thing.
Yeah, we haven't done too much on the application level there. It's like most of the stuff I've moved into that is really just system level stuff. So like I said, doing Docker prune kind of stuff. Some jobs that just get run every so often, that kind of thing. So it's helped me move a lot of our infrastructure layer stuff up a bit, so it's a little more manageable. Not at the host level anymore. I don't know if we have any plans for application batch processing kind of stuff.
Yeah, so I think few things which I have found it might be useful. For example, cron jobs, I think we have many of our Swarm services have a extra sub-service called cron, which does some amount of pruning. And I think if you end up using Kubernetes, we don't need to have a cron container and then put the application on top of that. So I think that's something which will be really useful for us. Apart from that, I haven't seen a specific need per se. Yeah.
You mentioned something about console, some issues you ran into using console with Kubernetes. Can you highlight them?
Yeah, so the problem with console is, well, at least the way we've been using consoles, we were using a tool called Registrator. So it would see when a container launched on a host with a port on that host, and then it would register that service and port into console. With Calico, the container doesn't actually have a port open on the host. It has a port open inside of the Calico network. So Registrator doesn't see those. I think there's been some patches submitted to Calico to try to fix that, but I don't know if they've been merged or anything. So by default, Registrator is not going to see anything running in Calico. And also, as well as that, the reason that we're staying out of using console for Kube is because a lot of our stuff is still outside of the Kubernetes cluster, which means it's outside Calico. So even if we could register a Calico IP into console, a lot of things couldn't talk to it. So we need things to be exposed externally.
No more questions? All right, let's give these guys another round.
Thank you.
Thank you.
Thank you.
That was good.
Thank you.
Good job.
Thanks.